These are your notes for finding vertical and horizontal asymptotes. In order to find vertical asymptotes, you need to find the real zeros of the denominator. And in order to find horizontal asymptotes, we need to find the limit as x approaches infinity of Rx and the limit as x approaches negative infinity of Rx. In order to practice these two ideas, we are going to solve three problems from your textbook, page 201, numbers 41, 43, and 51. For the first problem, number 41, to find the vertical asymptotes, we do exactly as was stated. We set the denominator, find the zeros of the denominator. So set the denominator equal to 0 and solve. So x equals negative 4. So x equals negative 4 is the vertical asymptote for this problem. Next, we find the horizontal asymptotes. In order to find the horizontal asymptotes, we find the limit as x approaches infinity find the limit as x approaches infinity of 3x over x plus 4. Whenever you're finding the limit as x approaches infinity, you're only going to use the end behavior of the polynomials in the numerator and the denominator. The end behavior of the numerator is 3x and the end behavior of the denominator is x. Remember, the end behavior um, just tells us to use the term with the highest degree. In, and what results is something that cancels, the x's cancel, and I end up with 3. And so the limit as x approaches infinity of a constant is just that constant. So the limit as x approaches infinity of 3 equals 3. So y equals 3. This is our horizontal asymptote for that problem. The next problem we're going to solve is going to be a bit complicated, bit more complicated, I should say, for number 43, because the first step that we actually need to solve in order to determine the vertical or the horizontal asymptotes is we need to completely factor the problem. So in the last problem we didn't need to factor anything. In this problem we'll need to factor both the numerator and the denominator. So I'm going to rewrite this problem in terms of its factors. So in the numerator we have to factor the difference of cubes, and then the denominator we have to factor a quadratic. So in order to factor the difference of cubes, we take the cube root of the first, we take the cube root of the second, and we keep the sign. We forget about the problem now. Square the first term that we just used to factor, multiply the first times the second, and change the sign, and then we square the last. Negative 2 squared is a positive 4. So if we multiply this back, you'll find that x minus 2 times the quantity x squared plus 2x plus 4 equals x cubed minus 8. And now we need to factor the bottom. And this one is just reverse FOIL. So you know the two things you multiply together to get x squared are x times x. The two things you multiply together to get a positive 6 and that also add to give you a negative 5 are negative 2 and negative 3. The reason why we want to factor this first is because you'll notice that these two values cancel and we end up with the numerator. So in order to find the vertical asymptotes, we only need to use the denominator that is remaining. So x minus 3 equals 0. So there's only one vertical asymptote, and that vertical asymptote is at x equals 3. Okay? And moving down to find the horizontal asymptotes, in order to find the horizontal asymptote, we're going to find the limit as x approaches infinity. And again, we're only going to use the factored form of the problem. So we'll be finding the limit as x approaches infinity. So we'll be finding the limit as x approaches infinity of x squared plus 2x plus 4 all over x minus 3. Let me make sure that I copied that correctly. Yes, we did. All right. Um, so again, in order to find a horizontal asymptote, we use the end behavior. And so by end behavior, I'm going to rewrite this as x squared in my numerator, because the end behavior of x squared plus 2x plus 4 is x squared. The end behavior of x minus 3 is simply x. If you think about it, as x goes to a really big number, like a million, then the 4 on the end of this first term really isn't going to make a difference. 1,000,004 or 1,000,003, that squared term and that x term there really are going to determine the value. And then we can simplify more. As x goes to infinity, x squared over x equals x, and as x goes to infinity of x, it's going to go to infinity, which means that there is no horizontal asymptote. So all rational functions do not have horizontal asymptotes. But we have to go through this process in order to determine whether they do or don't. So there are no horizontal asymptotes to be had here. Okay, let's move on to the third and final example. In this example, again, we will have to factor both the numerator and the denominator first as our first step. And our numerator is the difference of terms that are, they're the difference of squares, but these squares are also powers of 4. So first I'm going to have to factor this using what I know about the difference of squares. The square root of x to the 4th is x squared. The square root of 1 is 1. The square root of x to the 4th is x squared. The square root of 1 is 1. And since it's the difference of squares, remember 1 will be a sum and 1 will be a difference. Okay? I need to factor that a little bit more, but let's go ahead and factor the bottom. The denominator is just a common factor. I can factor out an x. So I end up with x minus 1. But I need to factor this numerator a little bit more. So in order to factor the numerator, I notice that this first term is another difference of squares. So when I factor that, it's x minus 1, x plus 1, and then I still have the x plus 1. Sorry, I'm squeezing that in on the edge there. And then I end up with x times x minus 1. So again, we have something that cancels just like in the last problem. So my factored function here is x plus 1 times x plus 1 all over x. And the only thing that matters here actually is this x, because remember, to find the vertical asymptotes, you just have to set that denominator equal to 0. So the vertical asymptote for this problem is x equals 0. You mean and then as we move down to find the horizontal asymptote, again I use that factor form. I take the limit as x approaches infinity of the numerator and that denominator. So let's go ahead and write that down. So it's the limit as x approaches infinity of the numerator. And we have to think, what is the end behavior of this numerator? What is the end behavior of that numerator? It's x squared, and the end behavior of the denominator is just x. You'll notice that the x's cancel, and we end up with x. And again, the limit as x goes to infinity of x is infinity. So whenever you don't get a constant as your answer here, then you simply have no horizontal asymptote. So this problem has no horizontal asymptote. And you can confirm all of these by graphing them. and looking at the graph. Well, that was it. That was the first three examples. If you have any questions, you can see me in class.